So you should all have the note sheet from yesterday unless you were absent, and you can come get it from me. And you need to be saving all of your note sheets for your binder test. That goes in the assessment category. It's not supposed to hurt you. It helps more kids than it actually hurts them. So I'm going to continue to put it into the assessment category. Because unlike your other classes, how much are your assessments worth in math? 80% of your grade. So that's why we kind of get the exception to put things like binder checks in the assessment category to give them more weight. Now, if you decide not to take any notes, or you decide to lose all your notes or not really care where you're putting them, that has a big effect on your grade. So, and especially with this unit 2, you know how many lessons there are in unit 2? We're currently on lesson 12, but you know how many there are total? 26. 26. And what I usually do for binder checks are that every note sheet, and it's one per lesson, some of them there's more. Okay, I'll wait. That can be your time to practice. I don't care. All right, but the way that I usually count the points is that every note sheet that I give you, and for most lessons, it's one per lesson, so if it's 26 lessons total, I times that by 2. So that would be 52 points going into the assessment category for having all of your note sheets, and not necessarily do we fill out every single note sheet, but I know what parts we fill out. Right? All the parts that we do together should be filled out on your note sheet. So they shouldn't be blank binder check time. They should be filled out. And if you're absent, then you can do them on your own paper. If you already lost them, we're not that far in. We're only on lesson 12. So you can go back to Schoology, watch the videos, take your own notes, or copy the notes that are also put into Schoology. So there's really no excuses. I'm gonna probably have to send an email out home soon with all the F's and B's that I have in the class to notify your parents. And then also just reminding them, like, hey, binder checks are worth a big chunk of your grade. This next one's gonna be 52 points. We'll get it together. Question?
Is that today?
Is what today? The binder check? No. The binder check is due October 25th. That's a date for the unit test. Unit test will be October 26th, so the binder test will always be the day before this. All right, any other questions? It is, so that's why you have to memorize everything we're doing so far. Take good notes, not lose your notes, do well with kids in. Yes. We'll add you to the line. So then, lesson 12, we are finishing today. The main goal of lesson 12 is to recall what it means to solve a system of linear equations and how to do it by graphing. So I'm recording right now. I also included yesterday's lesson in the slide because they go together. Mondays and short days. The puzzle piece is lesson 12. You will have time to work on it today, unless of course things go bad and you guys talking cuts into that time. So should have time today. I've been giving everyone about 15 minutes. But we do also have to start lesson 13 today, which we will. So that's why I'm timing you for 15 minutes. Because the mid-unit assessment, which you were supposed to take today, we bumped to tomorrow. So that'll be tomorrow, right at the beginning of class, because I didn't think we need about 30 minutes more. So I wanted if you to have time to work on your puzzle piece. It's over lesson 2.6 through 2.12. So that is why I have to give it to you tomorrow, because that'll be after lesson 12. So since it's over the same stuff as what we just quizzed on, the 2.6 to 2.11, then if you score better on this test, then I'll replace the bad score automatically without you doing anything. Either way, they're both going in the grade book, so you can still try your best on it. questions on that? So it shouldn't surprise anyone that we're quizzing tomorrow because that has been on the schedule. All right, but here's where we left off yesterday. We finished with writing the equation to represent the new constraint of Diego buying a total of 2 pounds of raisins and walnuts combined. What was that equation? Good, x plus y equals 2 was the equation. I'll rewrite it over here as well. So we're gonna start with you and your groups using your graphing technology to graph that equation and to fill in the table, again, using your graphing technology. We went over how to do that yesterday. I want all of you to have your, either your Chromebook out or Desmos on your phone out or on your own graphing calculator. Right? Because that's the yell at my last hour. They're not. So everyone practice it. What should you have typed into Desmos? The equation, which is good. Type it in exactly how it looks. With Desmos, you don't even need to make it slope-intercept form. However, I know on your test, it might ask for it in slope-intercept form. Well, then all you have to do is identify your y-intercept on a graph and then the slope from it, which we have done before. But good. You get something like this. How do I fill out the table? Move the mouse on the line. So like you see what I'm doing, you see how I can see each individual point. Some of these numbers are rounded to like 3 decimal spots instead of 2. So I might want to even zoom in a little bit more. So that way I can see all of those when they come up. But what is the raisins? Are they the X or the Y? The X, because that's what we said X represents, pounds of raisins. What represents the walnuts? So then on my line, I want to know what the Y is when X is 0. What is it? 2 is correct. So that's what you all should have found. And if you didn't, do it now. Click on your line, find when the X is 0, the Y is 2. Coordinates always go X and then Y, so know your stuff. Then do the same with the rest. What is the Y when X is 0.25? All right, I'm trying to get it on the 2.5. There you go. It is 1.75. So that's what you should have filled in next on your table. That the Y is 1.75. Questions so far? You should all be paying attention to this. Stop playing with your hands, whatever you're doing. What is the X when Y is 1.375? Sorry, I have to scroll over. 1.375. Yes, you are right. 0.625. Everyone see it on the screen? Everyone making the connection? All right, these are all points that are on the line. So then what's the X when Y is 1.25? All right, good. It does happen to fall on the line. It falls on it right here. So it can also plot coordinates for you. That doesn't really help you in the finding. You do still have to drag and look. But yes, it should be 0.75 for the X here. What about when X is 1.75? What's the Y? 0.25. And what's the Y when X is 3?
Anyone disagree with that? I only heard Bailey, so hopefully you guys were able to find that. 1.75 comma 0.25. 3 and then -1. Look, they both are on the line. All right, stop talking. Here's the next part of this. Diego spent $15 and bought exactly 2 pounds of raisins and walnuts. So how many pounds of each did he buy? So now we're putting both constraints together. What do you think the solution is going to be? Well, this part is just from the x plus y equals 2. If you look up higher on your notes from yesterday, are there any coordinates that match exactly? Which one? So it's on this one, and it's on the one from yesterday, right? So that would be my answer, would it not be? Doesn't it make both true? So that would be my answer, which is the 0.25 represent. So the answer is 0.25 pounds of raisins. That's the shorthand for pounds, by the way, LBS. And how many pounds of walnuts? 1.75 pounds of walnuts. All right, we just saw that this on the line. That means that it adds up to 2 pounds, which it does. 0.25 is 1.75 is 2 pounds. But also when we plugged it into the other equation, it gave us a total of $15, which is how much we spent. So see what happens when we put our other equation into Desmos, the one from yesterday. It was 4x plus 8y equal to 15. All right, it graphs the line for you. Guess where the solution is on the graph. 1.875. One of you guys. That was me. It's where the lines intersect. Oh, because look, here's where they intersect. Isn't that what we said the answer was? 0.25 pounds of raisins and 1.75 pounds of walnuts. So it would be the same point on both lines. And they don't cross anywhere else. So how many solutions do I have? Just one solution. Questions on that process? All right, so then down here, we're going to answer some questions. Now let me formally define for you a system of equations. This is an example of a system of equations. The 2 equations that we had in the situation put together, and then usually we'll group them with that symbol. So what do we notice about the 2 equations? Do they have anything in common? They both have x and y. So to write a system of equations, they need to have the same variables. What else? Anything? Good, equal signs, because they are equations. The last thing is that there needs to be 2 or more equations. That's what makes it a system. The actual writing of the equation just depends on the situation, but it should look something like this, or maybe in closed intercept form. But I can tell you in all my years of like teaching this and doing examples of it, usually one of the equations was really simple like that, where it's like the variable plus the other variable equals the other that's going on.
So whether it's like pounds of raisins, or pounds of walnuts, or like hours mowing the lawn versus hours babysitting, whatever. It's budgeting for something equally something else. Just from my own experience. If you ever get stuck on writing your system of these things. So then, what is the solution to the system below? This is from the last problem. So what did we say the solution was? Good, so the solution to a system could be the coordinate. So like in your own words, the coordinate where what? The coordinate where someone said it. The lines intersect. That's how you know on a graph. What about not on a graph? Is the coordinate that not necessarily? It is the X and Y values that make both equations true. So this I would write down on the free space, maybe on the back. We're not actually going to do the activity that's on the back, as you know. So you can write this down. It's the coordinate where the lines intersect on a graph, that's how you know. But otherwise, it's the X and Y values that make the equation true. So like if I plug it into both equations, I do get equal, like two things that are equal. Like 4 times 0.25 plus 8 times 1.75 is 15. And 0.25 plus 1.75 is 2. So questions on that? Good. All right, if you're still writing down the definition, maybe take a picture of it or something, because we're gonna look at the next slide. All right, so then next page. How you can determine the number of solutions based on the graph should be super easy. You have 3 options, either one solution, no solution, or infinitely many. Why is there only one solution on the first graph? Because they only intersect at one spot. Now, a lot of the times after this lesson, I'll say, what's the solution to this system? And they'll just say there's one solution. If it says what is the solution, you actually have to tell me what the coordinate is. So what is the coordinate? Where is the coordinate at?
About 2.5. No,
Are you sure? Look at how this is labeled.
like 2/3.
2 point what? Good, we're just estimating, so that's fine. It's between 2 and 2.5. What about on the Y? Where does it look like it's at?
2.3.
About 2.3 again. Again, we're just estimating. But it's clearly between the 2 and the 2.5. That's a good estimate. The X and Y where they intersect. What about in the second one? Why are there no solutions?
Because the lines are parallel.
Perfect. They never intersect because these are parallel lines. What's the space between parallel lines? What do parallel lines have in common?
They've already done.
Other than that, they never touch.
They are the exact same. They're not, one's not gonna start serving and one is not serving.
Well, they're all gonna be straight lines in this unit, so none of them will curve. If I were to show you like the equation of these 2 lines, what would be the same about them? Everything. Not everything. The slope would be the same. So parallel lines have the same slope. Just so you know. So if I have two lines, stop talking. In slope intercept form, and I see them the slopes are the same, I automatically know that there's no solution. And they have to have different y-intercepts, clearly, you can see that they cross the y at different spots. They have to have different y-intercepts, otherwise, what? What happens if they have the same slope and the same y-intercept? Oh,
I said the same time.
Well, yeah.
if I have the same slope and same y-intercept, I have the same line, which is what it shows you in this last one.
Oh my God, what'd you get?
So if I have the same slope and the same y-intercept,
Problem.
right, stop with the side chatter. I get two lines that basically overlap each other. That's why it looks like it's just one line. Because really they're the same line, if they have the same slope, the same y-intercept. Then you have infinitely many solutions, because they're constantly overlapping. All of these would be possible combinations. Something else with this one. Be careful, like you might have two equations that look different. Like maybe I have it as this. And then the other equation looks like this. Are these equivalent equations? Yes.
Yes,
What did I do in the second one?
you just added it by two.
I just multiplied the entire equation by two. So think of it as a previous lesson when we did equivalent equations. Or equivalent ways of writing things. If I could manipulate it and get the others, then they're equivalent. Make sense? All right. So just be aware of that. That's how you know if it's one, no solution, or infinitely many solutions. Here is that definition again. We already wrote it down. The solution to a system of equations is the coordinate pair that makes both equations in the system true. Graphically, where they intersect. Good, any questions? So with that, I'm gonna start the timer and give you time to work on your lesson 12 assignment. Yes, that you will work on with your team. Agree on the answers before moving on. That's a great way to ask me for help, because if you disagree on something. Also, pretty soon, so listen, and I also want this recorded so that way you can't say I didn't tell you. Pretty soon, all the desks are gonna have this little paper on it. The whole right side of the room has it already. I'm having my TA, make them super nice on there, so don't mess them up. I don't wanna see doodling on them or ripping off the page or whatever. I know a lot of you like to write on the desk. I'm tracking down on it. I'm paying attention to when it pops up after what hour, and just have a CD chart, and it's pretty easy to figure out. This up, analyze it up, and don't mess up my little pictures. These are supposed to help you, talk to your teammates. Like when you disagree on something, like I disagree with blank because blank. In step blank, you miscalculated blank, not, oh, you're stupid, you don't know how to do it. Done. I'm cracking down on it, but just so you know. Work on your puzzle piece. You have 15 minutes to work together.